All right, welcome to Daily Leetcode JavaScript. Today we're going to be working on squares of a sorted array, which is problem 977. And the problem states, given an array of integers a that is sorted in non-decreasing order, in other words, in increasing order, return an array of the squares of each number, also in sorted non-decreasing order. Okay, so we have an example with some input and output. So the input is -4, -1, 0, 3, 10. And then the output is 0, 1, 9, 16, 100. So what this is stating is that the array is sorted in increasing order from smallest to largest. But then they want the result of squaring these to also be in increasing order. So 0 will be the the 0 raised to the power of 2. -1 would be just 1. 3 squared would be 9. -4, 16, and 10 is 100. So all this means is we're just going to take this, square everything, and then sort the result. So the brute force approach or the trivial approach would just be to create a new array and sort create a new array of the squares of these guys and then just sort that array afterwards. So that would be the brute force approach. So what that means is we would write, we'll just go through the original array for let I equals 0, I is less than a dot length, I plus plus. And then here we would just do a sub I times 2, and then we would push this into some array that we create. So temp array dot push, right? So then we could have this temp array here. And then we would just sort the temp array, and then that's what we would return. So we would return temp array dot sort, and then we would just do our regular sort function. AB and we'll return A minus B, and this should do the trick. Okay, but like I said, this is the trivial brute force approach. So when we sort, we're going to do something that's n log n time, which is not great. So we want something that's linear time, which is not amazing either, but it's better than n log n. So to show you the difference between those two times, we're going to go to our trusty desmos.com and n or x log x and just x. So as you can see, x log x looks better, but that's because it's on a very small input. But as soon as the input gets larger, then x log x or n log n in our case is going to get larger much quicker than the linear time. So we can definitely do better. We can do linear time with this guy here. So how would we do that? Well, we already know that we have essentially two arrays. we have negative and positive values in one array, but the array is already sorted for us. So one of the approaches we can take is to create two arrays for two different values. The first value is going to be the arrays on the left-hand side, and then the rest is going to be the array on the right-hand side. And then we're going to merge the two arrays. And when we merge arrays, we get our time complexity is big O of n. So what we can do is we can create a new, or let's call this neg array. And this is where the values of the squares of the negative numbers are going to go in. Then we're going to have pos array equals this. Cool. The next thing that we want to do is we want to iterate through our array. So Oh, can't type today. Okay, so then what do we do inside of this array? How do we get just the values of the negative numbers, or from negative whatever to 0 into this array? Well, that should be pretty straightforward. Just a simple if statement should let us figure that out. So if a sub I is less than or equal to 0, then we're going to do neg array dot push, and we're going to push in a sub I squared. Else, we're going to push into the positive array a sub I squared. Cool. So that should give us two arrays, one with the squares of the negatives and then one with the squares of the positive values. So the next thing that we want to do is we want to merge the two arrays together. And as a matter of fact, this should have been a push. Because we're starting all the way from the left-hand side, what that means is that the first item is going to be larger, 16, and then this one's going to be 1, so it's going to be in decreasing order. So what we want to do is we want to put this larger value at the front of the array. So instead of a push, I think a shift is in order here, or an unshift, I'm sorry. Okay, because what we want is this 16 to be, if the array is empty, is going to be the first element, right? But in the negative 1, we want to put that in front of the 16, or the value of the square of negative 1. We want that to be in front of the 16, which would be here at the 1, right? So that's the reason why we are doing it this way. Awesome. All right, so now that we have both of these arrays, we want to merge them together. So we're just going to write a little merge routine, and we're going to say while neg array dot length. So while we have an array with some length, either of these, so both of these have to have items inside of it for this routine to work. So if not, and I'll show you why here in a minute. So then what we're going to do is we're actually going to need a third array. Let results equal that. And what we're going to do is we're going to say result.push. And now I want to compare. I want to see if neg array, if the first item in neg array is less than the first item in pos array, then I'm going to push into result the neg array item. So we're going to remove that guy from there. Else we're going to put in the pos array item, right? And as we're popping, the arrays are getting smaller. I'm sorry, this is shift. Is that right? Yeah. So as we are removing items from the beginning of this array, the length is getting smaller. So at some point, we're going to have one of these guys that has 0 length. So we're not going to be able to make comparison anymore. But that means that what we have already is sorted, and then anything after that's left over in either this guy or this guy is going to be larger than what's already been sorted into the result array. Okay, again, so anything larger, anything left over is going to be larger than what's in the result array already. So then finally, what we want to do is we just want to return result, and it doesn't matter the order that we put the following to here. So we could have put pos array first in this position and then neg array here, because only one of these might potentially have more values left in it. All right, because we're going to break out of this loop as soon as one of those have a length of 0. So only one of these two are actually going to have some items inside of it. Which one is it going to be? I don't know. But that pretty much solves this problem, and this would be done in big O of n time. So it's better than the n log n as we saw earlier. So let's try to submit this code. Looks like it's taking a little too long. I might have had a typo or something somewhere. Oh, I got the wrong answer. My output was 901, 16100. What did I mess up? Oh, I didn't put the 0 here. Let's just test it locally here first. Okay, and let's try one more time. Cool, awesome. All right, so that solves it. I just forgot to put the index to check the first item in this array. All right, great. I hope you guys enjoyed this video. If you did, hit the like and subscribe button. The audio should be getting fairly better in the next few episodes. I just bought a pretty sweet microphone, so hopefully you don't have to hear this awful audio for much longer if you like these videos. So great. Have a great day.